I think that you guys have already heard a little bit about Red Hat's point of view on provisioning, like lifecycle management. I think this is, a topic that covers and interacts with a lot of the other topics. I think it's going to be super important and one of the places where we can start as a community and have, impact quickly, right? And I do want to throw it over to Dell to give a little bit of their perspective more on why this is such an important topic for them.
Hi, everybody. So I'm Boris in Diamond Bluff project. I'm leading the lifecycle provisioning subgroup. And let me share my slides. Today, we want to start the discussion of why this is important. Okay, see my screen?
Yep. It's up now, Boris.
Perfect. Okay, so I think that as opposed to the previous breakout session, we want to do kind of roundtable here and a little bit more discussion and kind of free thoughts. So I'm just kind of put this slide. We'll start going through these bullets. I only have one slide to show you. So this is just, to provoke the conversation and talk about the important issues here. For high level topics, those are the topics that we discuss in our subgroup. We feel that this is important to tackle those issues, and let's start. So discovery of the DPUs is way high on our list. So means network discovery and PCI discovery and whatever discovery you can think about. So you have a bunch of DPUs in your data center, how you discover new DPUs coming in. So this is one of the topics that we want to discuss. And you guys just feel free to unmute yourselves, ask questions, sidetrack me, whatever.
And it's part of the discovery process. It's not just discovering the DPUs, but then once they're discovered, we want to move into the inventory topic where they would basically advertise what services are available, what capabilities are available. If you're looking at this as a server and a server, how many cores are available? If it's a standalone device, again, how many cores are available, what kind of memory is available, et cetera. Because you need to understand what you can do with the platform once you've discovered that it's out there.
Yeah, so I split this in two different bullets. The discovery first part is just the discovery of the DPU itself. And what you're talking about, Mark, is kind of falls into the second category, which is inventory, which talks about what capabilities each DPU has and advertises. Could be amount of cores, memory, specific hardware acceleration, like compression, encryption, RAID, wherever you feel on your DPU to advertise. This will be gathered as part of the inventory that every DPUs will advertise.
And the inventory itself is also a dynamic characteristic as well. So as resources get consumed, the inventory gets updated to show both consumption as well as what's still available to be consumed.
Yeah, and taking it forward, like with scheduling of the tasks to the DPUs, that we feel that this inventory can help the orchestrator to kind of better match the tasks to the DPUs in question. Make sense, like the use case?
Do you think it's going to be like a real one-to-one from like the host CPU to the DPU, or do we think that, we're really going to be potentially having multiple different kinds of devices and then having to handle all of that in discovery as well? I mean, it feels like go ahead.
Yeah, I think that we're looking into much broader use cases here, not one-to-one from the host. Different vendors, different capabilities mixed in the data center. This is what we're looking for.
I would, a general comment, Thomas from Ericsson here, is that during these 2 days, we've had, I would say, 2 major groups of usages of IPU DPUs. One of them where it is an infrastructure device that should be fully owned and managed by the infrastructure, and the other one where it's just an add-on feature to the operating system running on the host. And I think we need to divide those 2 up, because in the first one, you will have probably 2 different authorities dealing with traffic inside the IPU DPU, and also 2 different life cycles of potentially code inside.
Yeah, I agree.
So from that perspective, there would be what, advertising to each of those entities, or?
Well, I suspect if you have that the infrastructure own the IPU DPU, then you would do a lot of different things on that level, which you will not allow the host to have any say in. I mean, for instance, it would probably not be allowed to do a firmware upgrade as one of the examples. That would only be done from the infrastructure itself. But you still need the host to be able to discover what it is, and maybe do an inventory of capabilities that it advertises in some shape and form on that level.
So
so
maybe
I
you're
think-
talking more about the access levels. So the DPU itself will advertise all the functions, but not to everybody at an equal kind of access level. So if host is restricted from accessing some of the sensitive information or controlling the DPU itself, it doesn't mean that the other host or service inside the DPU will not have more privileged, let's say, access. So from the APIs and capabilities perspective, we do believe that should be commonality and exposing everything, but with appropriate access level for security.
I'm not so sure on that.
Yeah, I would. This is Paul with Paul Carlin, IBM Research. I might say that, I mean, to me, the one use case I just heard about completely flips the whole security, who's in control.
Yeah.
Right now, the infrastructure is in control and CPUs are just another chip. And there's nothing particularly special about them, or at least, and the security all starts on the other side of the PCI bus. Is that what you're thinking of, Thomas? Not to put words in your mouth.
If the infrastructure owns this, then I would say that part of the IPU acts similar to the motherboard BMC. It is in a different security domain, which can't be controlled by the CPU. It's a different authority that owns that one. You have a different entry point of management going in towards the motherboard BMC normally, and you would turn off the host interface in the BMC, so you can't reach that and set up different things if you're in a cloud environment. And the similar thing should be if the infrastructure owns the IPU. Yeah.
Yeah, and we see similar things even with some private data centers where you don't want an administrator to be able to go in and in any way examine or tamper with what's happening on the servers, right? No offense, but why do we trust the admins?
I mean, both the good guys and the bad guys have access to renting compute space, so you don't want them there all the time.
So this is not a new debate, but I can tell you, talking to various kind of second-tier cloud companies and SaaS companies and enterprises, different organizations view the NICs themselves, even conventional NICs, as owned by the network group. Other organizations don't. There's obviously a case where the server owner, unless you want to go down the rat hole that people who run servers are incompetent compared to network people. If you just think about the case, is the server owner has responsibility for an SLA in the server, and now you're talking about upgrading firmware, for example, on a gadget that's in the box under their domain. So there is a social contract needs to come, but there, so some analogous things that happen. For example, in the storage world, fiber channel kind of ran into this, is like, who owns the configuration of the fiber channel host bus adapters and updating those kinds of things. So it's been done before, but I think this organization needs to accommodate both models, where in some cases it's going to be under the control of the server owner. In the other case, it's organized, or it's owned and managed by the network. And in the cases where the DPUs don't have a separate management port to get access to a local BMC, you have to deal with a case where in some people are going to say, I only want it configurable through the network side. I don't want it configurable through the host OS.
So
I think
since
there's actually
this discussion, go ahead.
I think there's actually a blended model as well, which we shouldn't overlook, which is that some of the infrastructure components need to be managed externally from the host, but the host itself may need to actually deploy certain services in the context of the DPU in order for it to complete its task as well. So, buried at the bottom of this list, it really should be at the top of this list, which is what is our security architecture that allows for the two extremes that Thomas, you were talking about, but also some form of blended model that allows the applications to do what they need to do as well.
I agree with you, but there needs to be some sort of a, what do you say? I would talk about it as some sort of a sandboxed environment for the host to be able to do certain things under the control or under the jurisdiction of the infrastructure owner in that case.
Yes, in which case we need a security architecture that can accommodate the blend that's going to occur in that scenario.
Do we assume that we would have only one DPU, IPU, whatever? I mean, we could partition it with multiple copies, right?
In the server, you mean?
In whatever entity, I mean, we call it a server, but in some environments, that's a pretty fluid cardinality, right, of IPU, server, whatever, CPU.
We definitely try to think about multiple entities.
I think that needs to be thought about in two different ways as well. I mean, you could have multiple hosts behind a shared NIC, which is a common cloud-ish type of a model. And you can have the inverse, that you have multiple different NICs on a server.
Right. Yes, I think that's a good, and I often ask, is the BMC an IPU or whatever we wish to call it? To me, it is, but again, that might be open to debate. Is the BMC chip an IPU or whatever, whatever we want to call them? To me, it is. Especially if you, the kind of things you were mentioning a while ago with the control, but that might be open for debate also.
I think it is
might have. No, I would agree that it does not. It is not the BMC, but it might be the gateway into the BMC.
Right. So in order to move forward with this discussion, and since this ownership topic is very important, so let me go to my backup slide and show you just a few thoughts. It definitely not covers all we discuss here, but a different kind of ownership or trust models between the platform BMC, let's say in the server, and the NIC BMC or DPU BMC here. So you can see clearly here I show three different types of trust or ownership. And you obviously also raised a few others, but this could, take the discussion a little bit further as well. So not joining the slide, but unmute yourselves. And what do you think about that? Does that make any sense?
I just kind of put this into the chat, but it does sound like there's security model design at the root of this, like being able to put the DPU in certain modes, like air gap mode, where it's fully sandbox, or partially sandbox, where you're providing a basic level of interaction and discovery to the host. And maybe even you're turning off SRIOV VFs to certain host contexts. And then there's a shared concept where maybe the host is actually party to deploying and managing services to the DPU itself.
Good point.
I think there's room for all of those, and those are all going to be customer use case driven.
And I would say, one thing.
that we have sort of used the term IPU is that in an IPU, the host is always not trusted. So as a default, an infrastructure device that's meant to run infrastructure applications is more like a switch where, you know, it can't trust anything that comes in on its interfaces. And one of those interfaces is a PCI. And I think that this is, again, just to avoid this ocean boiling effect where, you know, once you make that call, then, you know, you can get to some of these use cases again by building up trust through the system. But when you start with these options, it's madness, right? You just, you know, it makes your security model really difficult if this device that, you know, maybe is very complicated and very hard to understand exactly what's running on it, if it can sometimes, you know, have the back door locked and other times the back door is wide open. And so I think that, you know, if we want to pick something that's sort of manageable, starting with the first model there, host untrusted, is like the only way that I would put it in my network, is that I knew that, you know, the only way that, you know, people get onto it is if it's been authenticated and validated, and I know that the software running on there, you know, has been attested to be secure.
And when you say host not trusted, you mean the host is not trusted by default, but there are ways in which the host can verify its trustability.
Yeah, I think that the host, just because I'm plugged into its PCI, that means nothing, right? But
Yep.
if there's some software on there that's able to, you know, handshake and you know, talk to the other software that's running on the IPU DPU, then yeah, that's where I can establish trust, right?
So two routes of trust, one on the DPU and one on the IPU and one in the host.
I think that could be even more.
Yeah, the root of trust, I think, for the software that's running on the IPU DPU is going to not come from the host. So it could come from the host, but it's not going to be by the fact that you're sitting in a PCI bus.
Right. In other words, you need two. You need one on the IPU and one in the host itself, and the two can verify each other.
Exactly. Yeah.
So you really need to.
Why do you think it? Go ahead.
No, go ahead.
I'm not sure why I would think this software couldn't come from the host, but maybe I'm going to maybe back up. If it isn't too painful, just say when you say user, I don't know who that is, right? Is that an administrator? Is that the provider or an infrastructure user? Is that an end user? I mean, it seems like there's lots of users here, and I'm kind of disoriented looking at this picture.
I mean, in the case that I described, you know, it's the infrastructure provider, you know, who is managing that IPU DPU, you know, is going to be the one that's going to, you know, put the software, the infrastructure software on that device. And then, you know, that maybe that host is completely untrusted. Maybe I end up renting that host, you know, bare metal host to other, you know, end users, to tenants. So like I can't make any assumption about what runs in that host a priori. So it's a lot simpler to just make that IPU DPU device just treat that PCI bus like another Ethernet port, and you know, and then make that your trust model, and it makes things so much simpler.
Now, if we architect it properly, do we really have to make that distinction? Meaning, if we design the platform management in such a way that it doesn't matter whether the host is trusted or not. If the host is trusted, the operations would be governed from the host. If it's not, it's a remote entity. But we don't have to treat the host trusted model as a separate use case, right? If the interfaces are such that they can be driven from the host itself, that's fine. And the second point I was trying to make was that the one BMC model, I think, is kind of, unfortunately, a reality in a lot of deployments. So I think we may have to have some accommodation for that. It's not an ideal way of designing servers, but there are people who have designed it this way. So I don't know how we can ignore the one BMC model.
Yeah.
second point.
It's very similar to what's happening today in Dell, for example, when we sell servers with regular NICs before the DPUs, right? So the user can only see the platform BMC, and the platform BMC really manages the entire server. And the root of trust being established from this point forward. In the DPUs, I agree with Prasoon that many of the users, many of the customers will see exactly that model. Like still, the platform BMC is the entry point to the system. And then it doesn't really matter whether it's DPU with its own BMC. So the platform BMC will have to talk and authenticate the DPU BMC or the NIC BMC and the ARM cores and everything.
In my humble opinion.
That's right. Yeah.
Go ahead, Dan.
I was just going to say, I see the left-hand side and the right-hand side as the same case, where, you know, if you have the device and, you know, it gets authentic, you build up trust by, you know, having some sort of authentication path from the network, or, you know, and that network can be, you know, a link to the platform BMC. It can be over your RJ45, you know, special management link. I mean, it could be over the 100, 200, 400 gig links for all we care, right? But it comes over the network. You know, you have managed some sort of keys or some place for it to start to at least phone home and figure out who does it trust. And, you know, if it's sort of network managed, then you can just treat it like another network device in the system. And if the first thing it talks to is a BMC or something farther out in the network, from that point of view, that doesn't really change the security model.
It is a little bit, because if NIC BMC is behind the platform BMC, so the platform BMC and NIC BMC will have to establish trust between them, versus the first use case when you establish trust only with platform BMC.
No, but I'm saying use a networking protocol. Don't just establish trust because, oh, this came over NCSI and I trust NCSI. Don't trust it at the physical layer. Don't trust it because it came over PCI or whatever SM bus, right? You know.
No, but from certificates perspective and everything, right? Our platform BMC will securely talk to NIC BMC. Mark, you wanted to say? I'm hogging the mic.
No, it's okay. But Dan, even in the case that you're bringing up trust, I mean, you have a unknown trust basis just by saying I'm going to trust it over the Ethernet flow, right? That's basically what we need to define as we go through this, is probably to come up with what are the security domains that need to be addressed, and what are the trust models.
Yeah, Ethernet's not trusted. It's just that anything coming over Ethernet is some sort of higher layer protocol that has keys and handshakes and things like that. So yeah, I agree. And we need to create this security model, but that should be the basis. You should never trust it because, oh, it came on Ethernet port 1 or on the SM bus. So therefore, ergo, I trust it. It has to be something that's key managed, and then there's a chicken and the egg problem of, you know, how do you get the starting?
How do you get the keys?
So, and I think that's like the fundamental question of this whole thing is just like, well, once we establish the security model, how do you get the initial keys on there, and then you're off and running?
I think what you said before, Dan, is spot on. An encrypted call home service. So we do this with CPEs today, an encrypted call home service on the BMC. And in that specific case, I would like to treat the DPU as a completely separate server. It calls home, it gets a key, and that's how we authenticate. And in my humble opinion, we should not treat this as a NIC. So all of the mindset of we have a system and we have a NIC are not a good fit here, because the DPU is supposed to be, and I'm a little bit with F5 on that one, a full system, a full server, if you will. And as such, it should have a BMC. Think about bare metal use cases. Think about times you want to deploy a different thing on the card, on the DPU, where the host should not be affected at all. If I change images on the DPU and I need to reboot, why should the host be taking part of that? So I would say a DPU as a system and call home, some sort of an encryption call home service.
I agree with you a lot. This is an interesting use case, but the other use case we also have to tackle, because not everybody is a cloud provider. Not everybody is looking at those two systems as completely separate systems. Like sometimes you do see it as a very, very smart NIC, right? Or DPU inside the server. And some customers really want exactly that.
I was gonna
So
say
But are
that-
those
yeah.
incompatible? I'm not sure if those are incompatible. If we say nothing trusts anything, then the admin has to trust the DPU, and the consumer on the other side of the PCI device has to trust the other side of the PCI device. It feels to me that they're just completely independent entities,
Exactly.
which have to establish a challengeable a challengeable trust relationship before they'll ever do any action together.
I think
So
that's a valid use case, but not every deployment fits that model. I mean, there are deployments where everything is host driven. So I'm not arguing at all that DPU establishing its own independent identity and being managed totally separately from the server is a valid use case. I mean, that's certainly the direction things are going. But we cannot preclude.
I'm inclined to agree with Presume, but I'm sorry for interrupting, but let me just kind of describe what I think is going to be a scenario. Imagine a case where there's a large server buy and the customer gets talked into adding DPUs instead of standard NICs, but none of their software and infrastructure is ready. And so they need them to behave as a standard NIC until such time as they're enabled. So I'm not saying that's outside the scope of what you guys are talking about. I just want to note that there is this kind of how do you get this adopted, and not all the software is going to be ready at the time where people are going to want to put these in servers.
Well, I would say that in cases where we came across it, we have a BMC on the one hand, it has a port, external port, on the other hand, it's connected to the PCIe, so you can actually do both.
I mean, to me, the debate here points toward that we need a couple of logical constructs on if it is IPDK or if it is OPI level that basically describes the logical behavior of a kind of a system. And then we need to have a mapping down to different deployment cases or something like that. Because I mean, a couple of things you talked about is a NIC BMC could either be exactly that, a BMC connected to the NIC, or it could actually be an implementation that just runs code that we have established trust on inside the IPU DPU as well. And that's just a mapping down to a functionality that we need in the model, in the security model.
I mean, there may be cases where there's no BMC on the DPU IPU card. Then,
hope so.
So if that's the case.
If I can interrupt for a second, guys, just as a point of order, I think there's enough folks who want to talk. If folks could start raising their hand, then you get kind of a priority system.
Yeah, Paul just raised his hand. Yeah, Paul just raised his hand. Go ahead, Paul.
Okay, no, I think there's many valid use cases here, and I hope my position hasn't sounded like I'm trying to dismiss any of them. But maybe we just need to lay out some of those use cases to make progress. And perhaps that's too obvious, but I'm a little concerned that some of these use cases truly are not compatible, right? For example, if I just want to treat the card as a NIC, then it's just a NIC. Now it might be an incredibly capable offload device to do all sorts of magic things as a NIC, but it's still just a NIC. And maybe we just need some definitions and some use cases. Is that a reasonable way to make progress?
Yeah, no, I think we agree. That's why I was saying that, we've got to start looking at what the trust model views are. We need to start looking at some of these security domains, and then we can start mapping out the use cases. And then let's focus in on some of the key ones that we identify, because again, we could boil the ocean just here in security.
So you want me to go back and continue? Let's continue on the other items. If you have anything to add, guys, just again raise hand. We'll give you the floor. No problem. So once we talked about discovery a little bit, about inventory, and then about security quite a lot. So the next step that we want to kind of tackle is OS provisioning, like the device being deployed from the factory with some basic distribution. So how we kind of initially boot them into some coherent distribution base OS that we can provision on top of that actual applications, container services and stuff like that. And once we did that, so the next thing that we're trying to resolve is boot sequencing. Like you all guys said, that many of the cases we see that there is a host and there is a DPU. So what happens when the host is power cycle and DPU loses power, and it's not on auxiliary power, let's say, for just the sake of the argument. So what happens to the DPU? If DPU controls the host, so DPU will have to hold host in reset, something like that. So we're getting into the new area of boot sequencing, like who boots first, who holds whom in reset. So from infrastructure point of view, like you said correctly, DPU is in control, should hold host in reset, boot first, load everything that needs to be loaded, and then allow host to boot. And same goes with crash recovery. Like I said, with power cycle, but what happens if kernel crashes on the DPU? What happens if kernel crashes on the host? Like, how do we make sure that we collect all the information that we need, core dumps and everything, and then reboot in correct sequencing and correct order in order to system to be coherent going forward? So it's a huge topic. So any kind of comments or thoughts, welcome here before we move forward.
Yeah, from onboard security use cases, boot sequencing is definitely going to become a factor. You don't want to bring up host level resources until your security protections are adequately in place. So there will have to be something to address that. Also I think from the storage perspective, like we would, as some of the DPU vendors here during these two talks discussed, we can present emulated devices to the host, so we can actually boot from those emulated devices. So we cannot boot the host until the emulated device is presented. Yes, Dan?
You made my point for me. Yeah, is that we've just been with Lifecycle, we've been making the distinction between device lifecycle and node lifecycle, and they at least the way we have it on the that we put in the IPDK document thus far is that they can end up using the same mechanisms. So we just have to make sure that we have it, keep it clear in our heads that, you know, okay, are we giving a boot disk to the infrastructure device? Or are we giving a boot disk to the infrastructure device so that it can boot the bare metal host, or it can boot the, you know, the 15th VM on the system? So that is another place where we could descope and say, no, we just want to get the device lifecycle working. But they seem to be really related to one another, just like you were saying with the boot disk.
Yes, Ted.
I was going to make the same point that Carl did just at the end there, which is there's a dependency tree we also need to pay attention to in the lifecycle management to make sure that you don't take the DPU or the host into a configuration, into a version that's incompatible with the software running on the other side.
Thanks. Since I'm presenting, I'm not monitoring the chat, so if you see anything interesting, just unmute yourselves or call it out.
I'm trying to watch it.
Anybody from the chat want to unmute? Yeah.
Oh, sorry.
Go ahead then.
I meant to raise my hand. I think I lowered it. I need to learn how to do this. We did start some lifecycle management details in the target abstraction interface on the IPDK website. So would definitely love people's feedback on that. You know, what we did was we started with sort of the set of functions that you can call from OpenBMC, and tried to specify those as sort of the baseline set of things that you would need to be able to manage this type of device, like we didn't get into the secure boot stuff because I feel like that might have been, maybe that's expert level, but it was simple stuff like, how do you get a new image? How do you reset? The whole system? How do you reset just the cores inside the device? And then how do you, how do you recover it? And then how do you, get the sort of basic debug stuff that you can get out of a BMC, like the dump files and the log files. So we put that there. And again, it's ripped off of OpenBMC like directly. And would love to get people's feedback to see if that's a good starting point or if we need to think about a different starting point altogether. I think that this conversation though, really is motivating me to maybe step back in that interfaces document and really define these things that we're talking about here, is to say, all right, what's the security model? What's the trust model? Just so that at least those assumptions are documented there. So I'll definitely add that, but any feedback is welcome. And again, that file is open source, so we can just add and delete things. It's not as easy as Google Docs, but at least we can have the conversation there or in Slack.
Thanks, Dan. Thomas?
Yeah, I want to add, beside OS provisioning, I think key provisioning. And there are a couple of set of keys. I mean, both encryption keys as well as maybe keys for these authorities in the security model. And they could be added at different points in time. They might be fused as well. And we're having a discussion now about a scheme that we would like to implement, at least, that has a number of different stages where you need to inject and safely store keys as well. So I think key provisioning in some way is important as well.
Absolutely, good point. Yes, Joel.
How many of these lifecycle management questions would actually be resolved by the choice of OS, base OS?
I don't think many. I think it's kind of separate.
Yeah, I agree.
Okay. I know that
Paul?
there are some. I know that there are some like rel edge, for example, contains specific logic for OTA updates and crash recovery. So I'm just wondering whether OS choice dovetails into at least solving some of these things.
If those are good concepts, we can definitely leverage good concepts, but I think we obviously would like to stay OS distribution agnostic and allow all the distribution companies kind of to equally enjoy the deployment, I would say. Yes, Paul.
Got it.
Hi, I was just going to go back to Dan's comment on a security model. Do we believe that we can have a single security model for the use cases that we want to cover? And I think this may go back. I mean, Joel, my knee-jerk reaction to does it depend on the operating system choice? Kind of my initial thought was, oh, please no, it has to be orthogonal. But then for some use cases, if the quote host operating system is in control of the whole thing, then maybe that is a valid use case, and that would be a rather potentially different security model than a cloud provider or a large data center where you really treat it as a cloud even though it's private. So I'm just wondering, do we think there can be one security model, or is that perhaps even too much to make progress?
I'll answer that. At Intel, security is woven in everything that we do, and that's a real thing. In that, we have to go through all these security analyses to get anything done, and so we can't make it complicated. So yeah, we kind of need a security model. Otherwise, they won't let us sell anything. So I do think you can get there. And in the comments here, someone mentioned that I think it was Kyle that the OS doesn't necessarily solve the issues there, and I tend to agree that you have to come up with a security model where, there's flexibility in the OS that's run on that device. And then you just have to create a set of requirements to say, well, if the OS has to participate in that security model, like in the key management or whatnot, then you just list those there.
But to me, in the entire system, right, the security model will probably have to encompass the OS, the applications, the humans, the non-human entity. I mean, that, it seems to cover a lot of territory. Do we want to bite that off? And if we do, so be it. But again, it just seems pretty big. Just a thought.
Yeah.
Either that, and if we want to bite it off, actually, I suspect that it's been in some ways dealt with it from the top levels to some degree. But okay, just maybe we can take something rather than invent it.
Oh yeah, absolutely. I totally agree with you. Yeah, I don't want to create my own threat model, security model. I feel like that there's lots of things that we can start with.
I think we have to bite it off as an architecture, even if we don't do the full implementation to begin with. Because if we don't get the overall architecture right, it's going to be really hard to implement some of the use cases we're talking about that may be slightly on the edge today, but are more likely to be mainstream in the future.
I also think that we need to start with, I rather feel that we need to start with a single security model, and then add more than just try to tackle all the use cases and several security models at once and never get done anything. Kind of.
Boris, I agree, and I would actually add one more thing to it. Let's try and focus on one use case completely, meaning let's take somebody from our end clients and tell them, tell us what you want. Let's start with one use case, see how many people like it. They can tell us how they treat the DPU, how they want to manage the DPU, and let's bring it to the community and ask it, does this make sense? And based on that, let's start and focus with one use case. And I apologize, I have no way of raising my hand on this, either because I'm Israeli or because I'm using the Chrome version. But in any case, I would suggest focusing on one client.
Thanks a lot. Dan, Joel, you just want to lower your hand, or you want to actually unmute yourself? And then if Joel is not speaking, you can speak.
Yeah, I was just going to say the first use case that we've been working on has been bare metal hosting, because it's the simplest one. It's also sort of fundamental to a lot of the other use cases. So if we had to pick one, it's a really good one to have, because you have to basically the host is a black box, so then that problem's solved. And then all of the things that you want to do with bare metal hosting are related to virtual networking, virtual storage. And being able to, in the future, put Kubernetes or whatnot on top of that, bare metal hosting is a really, really good use case to start with.
Yes, Thomas.
Although I respect what you just said is that many people are using that kind of a model, I think we are starting from a completely different one, where we would like to place a DPU in an edge server sitting far out in the network, simply alone out there, very, very untrusted until it started, being the root of trust on an end of a VPN, which is a very, very different use case from what you have. And if
kind
we
of
should
standalone, Thomas, without any additional servers, standalone DPU connected to the VPN?
It would be an IPU that would be the root of termination trust of the VPN until we can boot the motherboard CPU. And then we can start trusting that. That's the use case. But it would be very, very, it would be like the IPU is the root of trust until the rest of the system is proven to be trusted. And we need multiple different sequences to be able to establish that with call home functionality to establish that we have the right thing out there. But what I'm describing is just, it's very different from the first use case you took there, Dan. And if we are concentrating on one use case and do that for half a year, then we're not spanning out space good enough to get a good interface, I think. So I think that it might be good to start with one use case, as you say, and maybe bash that for whatever, a month. And then we take another one and bash that for a month and see where do we end up before we sort of decide that we go all in on just one model.
I agree.
Yep.
Thanks, Thomas. Yes, Susan.
We are at time. So
Oh,
I
okay.
want to, I do want to thank everyone. Obviously, this is a very robust conversation. I see it's still going on in the chat window. And clearly there's a lot we can do as a community moving forward.
Join our subgroup and you'll learn more.
There we go. Thank
Yep.
you.
Either fill out the Google form, or both project websites have linked to Slack where you can connect with others to find out how to join. But yeah, reach out to us and help us with this.
Yes.
Great. So with that,